Hello everybody, hopefully you guys are having a good day. My name is Eddie and welcome back to the channel. I'm going to be doing another one of my stand-up videos where I talk about a feature I've been working on and explain my thought process while developing it. Hopefully you guys are liking these videos. Give them a thumbs up if you are. Comment down below any questions or comments you might have. I read them all. And subscribe to the channel so that you guys don't miss out on any future content. Cool. Now that we got all that housekeeping out of the way, we can get into what I want to talk about today. And it is the updates that I've made to the front end of the rings here. Let me just grab a token real quick. Sure we got that there, and all right, cool. So we've gotten a lot of work done. I think I went over the data structures that I was building out to store all of this data. Now I want to actually go over how I'm taking that data structure and populating it with all the information from the Kubernetes API. So we have a bunch of stuff here, like the name of the pods, cluster names, cluster CPU and memory usages, CPU usages for each pod, and memory usages for each pod. And also we have CPU and memory limits now. Just added that tonight, which was really fun. So it's pretty simple. We just have this one API route that we get that one data structure that you guys see here in the console log. If we pop this bad boy open and we look at the result and we look at the data that we get from it and we look at one of these and we can open up the kube and boom, boom, boom. All right, there we have a fully opened up cluster node with all the information. The way that we populate all that is with this one API call. I believe initially I went over a lot of this stuff. So we've talked about the SSL context and stuff like that, where we grab that from our Kubernetes configuration area. I'll show that off over here. You go into the configs, you have all your configs here, you could add a new one, you give it all the relevant information, and boom, that's how we're doing the connection here. I did that in a previous video, so maybe I'll be smart enough to put a tile here, but if not, just search through the stand-up playlist and you'll find it. Right, so the new stuff. I believe we've gone over this part too, but we have all of these API routes that we use. The newest one is that now we actually do query the API's metrics server that we didn't actually have before. kubectl get pods, get them all, and I believe inside of here there should be a metrics server somewhere. Maybe not. I thought it was in here. Oh no, here it is. So basically this is just a pod, a daemon pod, I believe, that actually runs on the servers and gets all the metrics that we use to pretty much tell us how much resources everything's using. Sorry, doing multiple things at once kind of makes my brain go freeze. All right, so we've probably gone over how we get nodes, how we're getting pods. Yeah, we talked about all of these routes. Getting oh, this is funny. Oh, okay, yeah. We need two different ways of getting metrics. One way for getting pods and one way for getting nodes. This is the brand new stuff. New stuff, old stuff. Cool. So that just does an HTTPX request over to the Kubernetes control plane, and the control plane gives us back some JSON that we read to do our stuff. Actually, let's see. I have a good one here. Yes, I've been using JQ a lot more. See here, and you could actually filter down data to get just what you want, so you're not getting displayed a bunch of data. Where before I'd probably do something like this. I'd be like, oh, I just want the first one to kind of see what's in there, and then I'd start filtering it down from there. But you can actually just leave this blank, and it'll grab everything from inside of one and give it out to you. So it'll say like, oh, you want every single item, but really all you want is the spec inside of items, and inside of that you really just want containers, and there might be multiple containers in this list, so you just want everything inside of there, and you really only want the resources that they're using. So we end up, instead of like a big thing like that, we end up with just the resources that are being used for each container inside of each pod. So yeah, that's a cool little extra tidbit if you don't know how to use JQ like that. Really great tool, love it, can't recommend it enough. All right, now let's get back into this. I'm probably gonna have to split this into multiple videos because this may look very simple here at the top level, but once we start getting into it, it's gonna compound in complexity. But we just get a list of nodes is what we want to build. So at the very top level, we want to make a list of nodes, and what we're doing at the end of the day is pretty much adding to this list of nodes. List of nodes append right here. Yep. Which is actually funny because I think this should go at the end. Yeah, it doesn't really matter because the way Python does memory, but this probably should go at the very end of everything that we're doing. I'll probably move that after this video. Cool. So we went over our last video of what a kube node is. It's just a data class with getters and setters, a couple of validators for the data, and it's basically what stores all this stuff here, right? And we just start grabbing stuff that we need. So the first thing that we need is the metadata. The metadata is going to give us the node name, and with that we can just instantly set it to kube node name equals this inside of the response we got, right? That all makes sense. And then the first place where really difficult stuff starts to happen, we can go to the definition, is to set resource allocatable. Basically, this is what we use to get the overall resource usage. And really all we're just doing is those same get things that we did in getting the name, but we're looking for more granular data. So in here, we're getting inside of the statuses, looking in allocatable, and then we're getting the CPU and the memory out of those. We're doing conversions, so I don't think I've talked about these yet, but these are just util functions that I've written out to basically get us the correct metrics. The Kubernetes API might give us the data. I'm going to use memory right now because I confused the hell out of CPU resource units. So in memory, you might get it in a kilobyte or a megabyte or a gigabyte or a terabyte, petabyte, exabyte. Those are very high. I don't think there's any exabyte memory servers, but I wrote my function out here because I'm going to use this same thing for storage later on. Right, you might get it in all those different values. You never know what the Kubernetes API is going to throw at you. Just the other day, I had a bug where it was giving me CPU units with a trailing U, or I believe it's micro cores. Yeah, micro cores, that's what it was. And I wasn't actually kind of handling for that. And then when it got, it's like, hey, we can't convert anything with a U in the end of it, so you're out of luck here. Right, because what we're actually doing at the end of the day is we're removing that trailing thing that denotes what unit your integer is, to make it into an integer, to then multiply it and make it into one base unit. And that's what these functions do. Really long roundabout way of saying what these functions do is I want the data that I'm getting from Kubernetes to be one base thing, right? If it's like storage or RAM, I'm gonna just store that in bytes, all right? And then when that data gets to the front end, then I'll convert it into something like megabytes or gigabytes or whatever, right? You could see here the data for memory. That's a huge number, but that's because it's coming in bytes, and then on the front end, I just convert it over to something that a human could understand. Our small human brains can comprehend. Yeah, so those are all the unit conversion stuff. I had to make a couple of these, basically convert CPU units into nanocores. I had to do convert decimal and binary. There's two different ways that that Kubernetes is gonna give us data. It might give it us in the decimal format, which is the like 1012 or whatever, or 2084 or 2048, you know, to the power of twos kind of things. Or we might get them in just, you know, base 10. We never know, you know, Kubernetes is wild like that. So you never know what it is, so we create this extra function that'll check, you know, is it a KI or is it just a K? Is it an MI or is it just an M? You know, are we dealing with a binary or a decimal unit? And then, you know, it chooses which one to convert it. So it's a little data pipeline, you know, the data first comes into here and it figures out which one of these two we want, and then it runs our conversion functions accordingly, whichever one, and then whatever we get back from there is what we return, or, you know, we give an error. For CPU, it's a lot easier. There's not the two different units that we have to deal with. Cool. So we convert those and then we just set them to our kube node. This is a very functional function in a way, you know, we give it a are these called monads? I never know. All right, I'm gonna have to do some reading for whatever functional programming is, but we give it a, you know, singular unit, our kube node, we mutate it, and then we give it back. And the node is just the data. That's the JSON data. Cool. Let's see. After that, we just make an API call to our metrics to get the metrics for the node. So now we've gotten the, oh, I just realized that I have a huge shadow on my face. Yeah, so we get the metrics. This is our total resources. So if the node has 4 gigabytes of RAM, that's the total, that's the allocatable. And then we want to get the actual metrics, how much is being used by all of our processes. And we kind of do that same exact rigmarole, right? we find the CPU and memory usage, we convert those either into nanocores or into bytes, and then we set them on our kube node, right? You're kind of seeing a pattern. We evaluate and then we express, you know. Solve circle, yin and yang. Read your SCIP, Structures of Interpretation of Computer Programming. Or not. That book breaks my brain every time I open it up. I think I've only made it like a couple chapters into it. List of nodes, and then we append here. All right, this append, I'm just so scared every single time, you know. You know that thing? It's like I'm gonna, what the heck? Pressing the wrong keybinds. Boop 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 boop. I've completely broken my program. Alright, everything still seems to be working. Alright, yeah, it updated. Oh my god, I didn't do anything. Cool. Perfect. But it doesn't really matter, right? Because even though these are just copies, these aren't any new entities, right? So if I append here on line 157 and then update the object inside of it, down here it doesn't matter because they're copies of each other. We're not copies. They're in-memory copies. They're the same. They're pointers. That's what it is, right? I don't know Python. Gosh, they're pointing to the same memory address, the same object. It's not a copy of the object actually, right? So they're not copies. They're just pointers to the same data on memory. Cool. All right. This video's getting pretty long, and going on from here to when we actually get how we do pod stuff is going to be a lot more complicated, and I want to save that for another video. So I'm going to end it here, and I'm just going to record the next video right after that. So hopefully you guys enjoyed this, and you guys got a good look at kind of how you develop out an API endpoint like that. And you know, you just evaluate the data and then you do some expressions on it and then you send that back. You know, you don't have to do some crazy object-oriented stuff with mutations and factories and all that kind of junk. You can just, you know, have data, go through a little pipeline, and come out the other end, and everything will be all right. So hopefully you guys enjoyed that. Yep, you know, like the video if you liked it, subscribe to get the next one, and comment down below if you guys have any questions. Bye bye.